Hi, my name is Tianle Liu, and I'm here to do the homework 6 problem 1. And for this one, first one we have the f function with the x and y, which is this one, and the range of the x and y. Right? So for the first one, we know that we need to find the valid joint density function. So we need to find a. Based on clues, we can write this formula. Both from the -1 to 1 is via the uh, range of the x and y. This one, and do the integral, we will find it's equal to 4 over a. And to make it a valid joint density function, we need to make this one equal to 1, which leads to a equals to 4, which we find the a for this valid joint density function. So that's done for question 1. For the question 2, we need to find whether it's uncorrelated. For this uncorrelated, we based on the clues, we can do we can calculate the expected number of xy first. Which is using this formula. Uh, by doing the calculation using the integral calculator, we'll have this one. This is for the first step for the integral, and through the integral using integral calculator, we can find it equals to 1 over 9. So for the expected value of the x, for this one, we will have equals to 0. Uh, Usually to this step, we can just stop here because the expected value of the x equals to 0, which means the multiply of the expected value of y and x will never be the 1 over 9. But for the complete steps, we will also do the expected value of y. We'll find it also equals to 0. So with this one, we can have inequality like this. Sorry, which leads to the result of the x, y are not uncorrelated. So this is it uh for the problem 2. Okay, so since the result of the uncorrelated is the negative, we can also get it directly from that x, y are not independent. Excuse me. So let's get the questions easily. For question 4, we need to find the joint density function of the x square and y square. So based on the lecture and the clue, it seems like we need to do an assumption of the z and w, right? For z, we make it as x square, for the y as y, for the w as y square, and we need to find the Jacobian, which is like this, right? And do it's the 4xy minus 0, which is the 4xy. Like this is a Jacobian. And based on this, also we can see as the combination of the x and y for the z and w, we will have four combinations. So which means we will use the four combination for the Jacobian in the next step. And for now, since it's the x square and y square, z and w also is larger or equal to 0 and let's say less or equal to y 1 for both z and w, right? And based on x square and y square, we can get x equals to square root of the z and y equals to square root of the w, which means that the Jacobian will equals to 4 square root of z square root of w, right? So for the fjw, excuse me, sorry, fjw based on the clues, we'll have the j1 is the fxy, sorry, fxy square root of z square root of w plus j2 fxy plus j3 fxy and j4 xy. Right? Based on this one and clues, we will get 1 over 2 square root of z and 1 over 2 square root of w directly. And this is the answer for the FCW when z and w satisfies this range, this domain, and 0 for the FCW otherwise of the range. And that's it for the problem 4. And for the problem 5, we'll have the we will have to do the independent test. By the information above, we will have the fx equals to oh yeah, fx equals to 2x 1 over 2x, fy equals to 1 over 2y, which will tends to fz equals to 2 square root z, 1 over 2 square root of z, and fy equals to 1 over 2 square root of w. And we can easily see that fzw equals to fz multiplied by fw, and which means I think, oh yeah, z and w are independent. X squared, which means x squared and y squared are independent. Okay, so that's it for the problem 1 for the homework 6. Thank you.